We basically live our lives online now, right? We're relying on dozens of apps and services every single day. But have you ever stopped to think about what happens when that crucial piece of software suddenly breaks? Well, today, we're going to crack the code on how a new generation of AI detectives is solving these super complex software failures, sometimes in just a matter of seconds. So, picture this. You go to open your favorite app and nothing. It's just spinning. It's super frustrating, right? But behind that blank screen, a kind of organized chaos is kicking off. A whole team of engineers just got an alert, and a high-stakes digital investigation has officially begun. You see, behind every single one of those outages, there's a process called incident management. And really, it's just a high-pressure race against the clock. Engineers are scrambling to find one tiny little fault before it triggers a massive system-wide meltdown, which, can cost companies millions and just annoy all of us. Now, to get why this is so hard, you have to understand that modern apps aren't just one big block of code anymore. Nope, they're more like a huge, tangled web of hundreds of tiny, independent programs called microservices, and they're all constantly talking to each other. It makes them really powerful, but it also means one little hiccup in one service can cascade and just bring the whole thing down. And finding that one broken link in a web of hundreds, it's like finding a needle in a digital haystack. So every investigation follows a pretty clear path. First up is Anomaly Detection. That's the alarm bell going off, saying, hey, something's wrong here. Next is Failure Triage, where engineers try to figure out, okay, what kind of wrong is it? Then comes the most important step, Root Cause Localization. This is all about finding exactly where the fire started. And only then can they get to incident mitigation, which is, actually fixing it. Today, we're zeroing in on how AI is totally changing the game for those first three super critical steps. So, you might be wondering, why do we even need AI for this? Well, the biggest challenge is that engineers aren't short on clues, they're literally drowning in them. The old tools and doing things by hand, they just can't keep up with the insane amount of data that modern systems are churning out every second. Okay, so the first kind of clue you get is metrics. The easiest way to think about these is like a system's vital signs, like heart rate and blood pressure. They show you stuff like CPU usage, memory, and how fast things are responding. So they're great at telling you that something is wrong, like a patient has a fever, but they almost never tell you why. Next up, you've got logs. This is basically the system's diary. It writes down every single thing that happens moment by moment. And a log file might contain the smoking gun, that one perfect error message like connection refused. But here's the catch. That one crucial message is buried among millions of totally normal entries just saying everything is fine, everything is fine. And clue number 3 is traces. A trace is like a GPS map for one single click you make. It shows every single stop that request makes as it zips through that big web of microservices. It can show you if a request is getting stuck somewhere, but again, the vast majority of traces look perfectly normal, which makes the one faulty path almost impossible to spot. So you see the massive dilemma here, right? The metrics show a symptom, but they don't give you the cause. The logs have the answer, but it's buried in a sea of noise. And the traces show a broken journey, but it's hidden among thousands of perfectly fine ones. Each clue is important, for sure, but on its own, it's just incomplete and totally overwhelming. And this all boils down to 3 huge challenges. First, the old tools, they just don't get meaning. They can count how many times an error happens, but they miss the actual meaning behind a message like database connection failed. Second, there's just way too much text for any human to read through in a crisis. And third, you can't just throw a giant AI model at the problem and hope for the best. A single model can get confused by all the noise, miss key details, or even worse, it can hallucinate and just make up a cause that isn't real. So to solve this massive puzzle, researchers came up with a new framework, and it's called TrioXpert. Honestly, the best way to think about it is like a highly specialized AI detective agency built from the ground up to crack these incredibly tough digital cases. TrioXpert's whole mission is to be the complete package. It doesn't just peek at one type of clue. No, it's designed to intelligently process and understand the metrics, the logs, and the traces all together, using a whole team of collaborating AI agents to figure out what's really going on. So, how does this detective agency actually work? This is the cool part. It's not just one big, monolithic AI. It's a team of specialists, and each one has a very specific job to do. Let's meet the team. The whole investigation follows three main stages. First, TrioXpert sucks in all the raw data and immediately starts sifting through it, filtering out all the noise to find the most important clues. Second, it builds a unified case file, kind of like a police dossier, looking at the problem from all angles. And then finally, the AI expert team gets together to deliberate and solve the case. First on the scene is the numerical expert. This is your number specialist, the stats geek. It pores over all the metrics and the system app, and its entire job is to spot weird statistical patterns and anomalies. This is the one that says, hey, the patient's fever just spiked. Next up is the textual expert. This AI is the language pro. It reads through all those filtered logs and traces, but it doesn't just count keywords. No, it actually understands the semantic meaning and the context of the words. This is the detective that finds that connection refused message and knows exactly what that implies. And that brings us to the incident expert. This is the lead detective, the head of the whole operation. It takes the reports from the numerical expert and the textual expert, compares their findings, and figures out how they fit together. It resolves any conflicts, and this right here is the secret sauce. By having these specialists collaborate and double-check each other's work, the system avoids those pitfalls of a single AI messing up. It's this teamwork that leads to a final diagnosis you can actually trust. Okay, so that all sounds fantastic in theory, right? A team of AI detectives, it's a great story. But does it actually work in the real world? Well, let's look at the results and see how TrioXpert did when they put it to the test. The results are, well, they're pretty staggering. In head-to-head tests, TrioXpert just consistently and dramatically blew all the older methods out of the water. It was better at detecting problems, better at triaging them, and most importantly, way, way better at finding the actual root cause. And the improvement wasn't just a little bit better, it was a massive leap forward. And I mean, this one number really says it all. For the most critical task, finding that needle in the haystack, the root cause, TrioXpert showed a performance boost of up to 163% over the other methods. That's the difference between an investigation taking hours and one taking seconds. And this is not just some experiment in a lab. The research paper talks about a real-world deployment at Lenovo. Get this, a problem that used to take a team of 3 human engineers about 2.5 hours to diagnose, TrioXpert can now solve in just 26 seconds. That is an absolute game changer. Okay, so let's bring this all back to us. Why does some advanced AI framework with a fancy name matter to you when you're just trying to get your app to load? Well, the takeaway is actually really simple. This kind of technology leads to more reliable digital services for all of us. It means that when things do break, they get fixed much, much faster. And that means less downtime for the apps and websites you depend on every single day. Plus, it frees up human engineers to work on solving bigger problems, not just digging through data for hours on end. And that leaves us with a pretty fascinating thought to end on. We are building a world that is almost completely dependent on software that's getting more and more complex every day. And as that complexity just keeps growing, you have to wonder, will AI detectives like TrioXpert be the only thing capable of keeping it all online? It's definitely something to think about. Thanks for tuning in.